Hello, my name is Hilary Weller. I work in meteorology at the University of Reading. I'm going to be talking about some figures from this book, Meteorological Measurements and Instrumentation by Giles Harrison, who is a professor at Reading in meteorology. This is figure 9.13 from Giles Harrison's book, and in a previous video I asked some questions about this video. I hope you noticed there were some errors in my questions. So this, in the previous video I had SG here and it should have been SB. In this video I'm going to try and answer some of these questions. So this graph here shows the top of the atmosphere radiation and the solar beam irradiance and the global solar on a clear day in Reading. The first question is, why is SB greater than SG throughout the day? So SG is the global solar radiation, so that includes the direct solar radiation and the diffuse solar radiation. That's the solar radiation that doesn't come directly from the sun. So you'd expect SG to be bigger because it includes the direct solar radiation and the diffuse solar radiation. So to answer this question, we need to remember the formula that relates SG, SB and SD. So the solar radiation directly from the sun is usually what we usually measure as the solar beam, which is in the direction of the sun. Whereas if we want to get whereas SG is just the downward component and SD is the downward component. So if we want to find the downward component of the direct solar radiation, we need to multiply by cos Z, where Z is the solar zenith angle. These measurements are at Reading, which is in the mid-latitudes, quite high latitude. So cos Z can be quite small. So in order to get SG from SB and SD, you have to multiply SB by cos Z. So then the global solar, the diffuse is small because this is a sunny day, so most of the solar radiation is coming directly from the sun. So SD is small, so SG turns out to be much smaller than SB throughout most of the day. Next question. So this is the question that had the error in the previous video. Why is the top of the atmosphere radiation bigger than the solar beam at around midday, but otherwise it's the other way around, the SB is bigger? So to answer this question, it's helpful to remember that the top of atmosphere radiation is equal to S times cos Z, and so S is the radiation that's coming directly from the sun, and STOA is the downward component. So it's so S is like SB but at the top of the atmosphere. So in order to get STOA from S, you multiply by cos Z. At around midday, cos Z is smallest. So STOA is at its maximum. So then SB is smaller than S because of the all of the reflection and scattering in the atmosphere, but then the rest other times STOA is made smaller because it's multiplied by this cos Z. So at midday, STOA is biggest because this cos Z is biggest, and at other times SB is bigger because it points directly at the sun, so it doesn't matter what direction the sun is coming from, it's still big. Whereas this STOA is smaller when the sun isn't overhead. And finally, why are the dots above the dashed line here? So the dashed line is where the SG is equal to, where the axes are equal. So that would be SG would be equal to SB cos Z. So that's two of the components from this equation here, SG and SB cos Z. And so SG is the dots are above the line, so SG is bigger. So the difference here is SD, the diffuse solar radiation. So you can see here that there is some diffuse solar radiation, so that there is some radiation coming from the rest of the sky, which Well, you can imagine there would be, because even on a clear sky, the sky is blue, and that's some light, that's some solar radiation. So those are my answers to those questions. I think please put some comments giving some better answers if you can. In this video I'm going to ask another question, but I'm not going to answer it in this video. So this is now figure 9.21 from Giles Harrison's book. I love the figures in this book. There's just so much. It's a book about instruments and instrumentation and measurements, but there's so much meteorology in it. There's so much to understand in terms of the meteorology. These are measurements of the top graph is temperature and humidity a day in Reading throughout the day, and the bottom one is the solar beam, global solar radiation, and diffuse solar irradiation throughout the day. So explain what's happening. Why are they all changing as they are? And my answers will be in the next video. Thank you. I hope you tune in for the next one, and please post some answers before or after looking at the next one.